Today we'll be going through set 20, graphs. So there are different types of graphs that you can see over here. So for example, there's a pictogram where one picture represents an X number of things. So for example, the pictogram over here represents a bicycle. One bicycle represents 200 bicycles, okay? And there's a pie graph where the circles divided up into little sections, and these sections correspond to the percentage of the things that are available, okay? And there's a column graph, which is the most common type of graph, and there's also a bar graph, okay? Bar graphs take a specific length and take the percentage of each thing that's available and attribute that to the length available. Okay, these are some popular graphs. So we just went through what the pictogram was, where symbols or pictures represent a certain number of items, and a column graph, the vertical columns, the most common type of graphs. Then there's the bar graph where a rectangle is used to show a fraction. And there's also sector graphs, which are also called pie graphs, where one circle is divided up into specific sectors, where the specific sectors represent a percentage of things. Okay, so to get that number, what we do is we get the whole number of whole items and then the number of items that we're using to represent. So for example, say there were 100 bicycles and 10 were red. What we do is we take 10 over 100, so the fraction over whole, and we times it by 360, okay, which would come down to 36 degrees. So in a pie graph, let's draw that, which is, you represent the red number of bicycles with 36 degrees, okay, something like that. And say the rest were all black, the rest will be 360 minus 36 degrees. As easy as that, okay? Let's keep going. And this is a line graph which shows the temperature during a 24-hour period. And we show the lines to show the progression of the temperature, if it's going down or up or staying the same, okay? These are some common examples. I want you guys to go through these and try to get an understanding of how each graph works. And we'll try some questions right after, okay? Just go through the step graph in a minute. With the step graph, it shows, and this one, for example, shows the corresponding weight for the cost of a parcel, okay? So the postage costs are calculated this way. For example, if we were to find out the cost of sending a parcel weighing 2 kilos, it will just be over here, between $2 and $4, right in the middle, which is $3. And we know that from here, from 1 kilo up until 2.5, actually not 2.5, it will be 2.5 not included, so it will be 2.499 kilos if we were to round it to 3 decimal places, okay? So from 1 kilo up until 2.499 kilos, the price will be $3, okay? This open circle represents that it's not included, okay? The shaded circle represents that it's included, okay? For example, how much do you think a 4 kilo parcel would cost? It's not this open circle that we look at the closed circle, the black shaded one, okay, which will be $6. Let's keep going. So let's have a look at travel graphs. When you're looking at travel graphs, the x-axis, the horizontal axis, represents the number of hours, like the time, and the vertical axis represents the distance in kilometers, okay? So if you have distance and time, to find the speed, we just look at the slope or the gradient of the line, okay? And if the line is like this, the gradient will be a negative, okay? So the speed will be a negative speed, Okay, steeper the line, the faster it is. So if the line's like this as opposed to a line like this is faster and the other one's slower. Okay, and if it's a horizontal line, you're staying still, the time keeps going and your distance keeps going as well. Sorry, the distance stays the same. That's why your speed is stationary. Okay, 0 kilometers an hour. And to find the average speed, you just do total distance over total time. So speed equals distance over time. Okay, we will go through questions like this when we're doing the questions in the next few pages. Okay, so practical situations, we use graphs for a lot of stuff: science, geography, economics. So for example here, we use a line of best fit to find out the relationship between mass and length. Okay, so when we have values like these ones, they're not always going to fit in one line. So that's why we draw a line of best fit without connecting the dots. Okay, let's keep going. Matching graphs. So you would also be given containers and asked to match it to a graph where it corresponds to a water level against the time. So for example, let's have a look at this one. The water level increases quickly because the mouth over here is getting steeper and steeper, right? And then from here to here, the bottleneck will be a uniform line, right? Because it's got the same volume from the bottleneck to the very top. That's why D is the corresponding graph for 1. Okay, let's do another one. What do we think B is? Okay, it's the same volume from top to bottom, bottom to top. There are no curvatures, there's nothing, it's just going straight up. So the water level will be stationary, like that. Sorry, uniform, not stationary. So that's why this is B. Okay, we'll go through graphs like this in the questions. Just have a read of this part and try to get an understanding of how to match these containers to the corresponding graphs. Okay, have a look at this one. A motorist drives at 80 kilometers an hour, stops for half an hour, and then drives at 60 kilometers an hour. Okay, which one do you think best describes the journey? Let's have a look. Remember, steeper the line, faster it goes. So, is this line steeper than this one? No, it's not. That's why this is not 80 and that's not 60. It has to be the other way around. So we can cancel this one out. What about this one? Is this one steeper than this one? I think it looks about the same. So we'll have to cancel this one as well. This one looks pretty steep compared to this one. And then we've got another horizontal line. What do you think this horizontal line represents? It represents the time that it was stopped for half an hour. Okay, and this definitely doesn't make sense. Whoops, went a bit up. Let's find our page right here. Okay, perfect. This doesn't represent anything because it's a curved line. Curved lines wouldn't make sense for speed over time, distance over time. Okay, so the answer is this one. Alrighty, let's start with our questions. Question 1. 2,000 households in New South Wales were asked how often they perform their grocery shopping. The results are shown in the graph below. Okay, let's have a look. Convert the information in the column graph into a sector graph. It will be a bit hard for me to draw on the computer, but I want you guys to pause the video and have a go at drawing this. So the steps to do this is to figure out what each time period like what value for each time period is. For example, monthly would be 50, and find out what's 50 over 2000 as a percentage. Okay, 50 over 2000 as a percentage would be 5 over 200. 5 over 200 is 2.5%, and then you find out what 2.5% is for 360. Okay, 360 times 2.5% gives us 9 degrees. Okay, and that's how you draw the sector graph or the pie graph and make it 9 degrees. That's not to scale, but you guys use a protractor and draw it to scale. This is 9 degrees, not 90, and label it as monthly. Okay, and you do the same for everything else. I'll just go through it with you so that you know if you've got the correct angles. Okay, fortnightly, there are how many doing fortnightly? There's, we've got 200 doing fortnightly. If you have a look at the graph over here, there's 200. Let's put 200 here, and 200 corresponds to how many degrees? Sorry, 200 over 2000 corresponds to how many degrees? So we put 200 over 2000, which gives us 10%. What's 10% of 360? 36 degrees. Okay, let's do weekly now. Weekly is around 1050. Okay, put 1050 here. 1050 over 2000 corresponds to about 189 degrees. Okay, we'll keep doing the same for everything else. So this is 150 corresponding to 27 degrees. 3 times a week is 400 corresponding to 72 degrees. Daily is 100 people, which is about 18 degrees. And then other is also 50%, same as monthly, corresponding to 9 degrees. This is what we should do before we start drawing our pie graph over here. Okay, now that we know what the corresponding angles are, we'll be able to draw the graph accurately. Okay, so you guys can use a protractor and divide the circle up into the angles that we've found out over here and come up with a pie graph that is representative of the sector bar graph over here. Okay, sorry, not bar graph, column graph. What we're supposed to do for A2 is to draw a bar graph. Okay, same as what we did before. Find out the percentage for each item here, so monthly, fortnightly, weekly, and then draw a rectangle and then divide the 20 centimeter rectangle according to the percentages. Okay, for example, we know that 200 over 2000 is 10%. 10% of 20 centimeters will be, I'm looking at fortnightly over here, the 10% of 20 centimeters will be 2 centimeters. So we dedicate 2 centimeters for this one and label it fortnightly, and so on and so forth. That's what we do for all the rest of the items. Okay, let's keep going. What percentage of households shop less frequently than twice a week? What's less frequently as twice a week? There'll be everything above twice a week. Okay, so weekly, fortnightly, monthly. Let's count how many people do shopping monthly, fortnight. That's right, weekly, fortnightly, and monthly. We've got 1050, we've got 200 and 200, we've got 50, so we'll add 250, which gives us 250, and 250 plus 1050 gives us 1300. Okay, and now to find out the percentage, we just do 1300 divided by 2000, which gives us 13 on 20, which simplifies to 65%, and that's our answer to B. Alrighty, let's look at question 2. The graph shows the journeys of 2 motorists traveling on the same road in the same direction. Mandy leaves from town X and Jung leaves from town Y. At what time do each of the motorists begin their journey? Let's have a look at the time over here. So Mandy starts at 7:30. and Zhang starts at 7 o'clock. Okay, so I'm just gonna do it here. 7:30, both AM. Okay. Next one. At what time do they pass each other for the third time? That's the first time, that's the second time, that's the third time. We'll see how long it'll be. Just work our way down. It seems just about right after 10:30. We'll just say 10:35 AM. Okay? Just to approximate it. We can't really tell accurately because the graph is so small, but if we had a bigger graph, we'll be able to tell it accurately, but we'll just approximate it for now. How far has Zhang traveled when Mandy begins her return journey? So the return journey will be the negative slope, this way. This is the going journey, this is the coming journey, okay? So this one's going, this is coming back. So when does Mandy start her return journey? Over here, okay? It'll be about 11 AM. We just need to calculate how far Zhang has traveled. Let's calculate it. 100. And then we've got another 80 here. 80 plus 20. We've got 200 kilometers. So Zhang's traveled 200 kilometers when Mandy is starting her return journey. Okay? Let's do 200 kilometers. And then the last one. What is the average speed of each motorist? Do not include rest time and answer to 1 decimal place. Okay, remember the formula to find the average speed? It's always distance over time, okay? What's the total distance traveled by Zhang? Let's calculate that. We've got 200 up until here and another 200 down. Oh, whoops. That should not have happened. There we go. So 200 uphill and then 200 downhill. Okay, and we're not counting rest time. Let's do it. Let's start with Mandy. Actually, Mandy's much easier. She's got 400 here. So 200 uphill, 200 downhill. And let's calculate what her time was. 7 to 9, she's traveled, so that's 2 hours, and then taking a rest for half an hour, and then she started driving again from 9:30 to, what's that, 10:30ish? I think 9:30 to 10. And then she's traveled again from 10:30 until 12:30. And then 1 to 2. This all comes down to 5.5 hours. Okay, so for Maddie, we'll just say M. We've got 400 kilometers divided by 5.5 hours. What's 400 divided by 5.5? That gives us about 72.7 kilometers an hour. Okay. Let's do Zhang now. Zhang starts from here. That's 20 kilometers less than what Maddie was, okay? So remember, that's 80 up until this one. And then from 9 until here, it's another 180. So that's 80 plus 80, 160. Then goes all the way down until 80 plus 80 is 160, and then here until here. Then 160 plus 180 gives us 340. So Zhang's total distance is 340 kilometers. Alright, now we need to find Zhang's total time. Let's see, from here to here, this is an hour. They can rest then until 9 o'clock, so an hour's rest. Goes back up until 10 o'clock, that's another 2 hours. Then started the journey again at 11 until 12:30, 3 to 4 hours, and then 1 to 2, that's another hour, which gives us 5 hours in total. Okay, let's do 340 divided by 5, which gives us 68 kilometers an hour, and that's our answer. Okay, so Maddie's traveled 400 kilometers in 5.5 hours, which gives us 72.7 kilometers an hour. Zhang's traveled 340 kilometers in 5 hours, which gives us 68 kilometers an hour. Okay, let's go to the next question. Which graph best represents the water level in each glass if they're both filled at a constant rate? Okay, remember here, there's a little, there's no curvature here, it's like a point, right? Very pointy here, meaning the water level will be stationary for a little bit. So just keep that in mind, okay? Alrighty. Now, let's have a look at this one. This has got a bit of a curve. Alright, since that's got a bit of a curve, we know that the water level is increasing rapidly from the start, from here to here, because there's more water, so it goes from less to more, and then over here there's a bit of a little stationary point of inflection. Okay, and then it goes from little water to more water, because at the bottom here there's little water, and at the top there's more water, so it goes something like this. Okay, that's the graph for A. It takes a long time to fill up from here to here, because the bottom is wider and the top's narrower, so it takes a long time. And then for this middle part over here, the curvature, it goes straight up, and then it goes the other way around, because it's narrower at the bottom and then wider at the top. So this will be the graph for A, which is 3. We'll just match that, and we'll use a different color for the next one. Here, same thing as last time, wider bottom, narrower top. So it goes something like this, and since the middle part is pointy, has a little stationary point of inflection like that, and then it keeps going from narrow bottom to wide top now. So same as last time, narrow bottom, wide top. Fills up easy at the narrow bottom, fills up slower at the wide top. So it's something like this. Okay, I'll just draw it better for you. Something like that for container B. What's similar to this graph out of the options here? I'd say 2. So we'll just match B to 2. Okay, and that's how we figure out the corresponding graphs for each container. Okay, I'll just erase this so that we know what the next question is asking of us. Okay, let's have a look. What is it saying? P is the point on the circumference of a wheel. Sketch a graph to show the height of P above the ground if the wheel is rotated clockwise from a position where P is on the ground. So clockwise is this way, where the clock is turning, and P is the circumference of a wheel. Okay, is the point on the circumference of a wheel, and P starting from the ground. So this is P, and they're asking us to sketch a graph to show the height of P in relative to the ground. Okay, so we can just draw something like that. The height would go on the y-axis, the vertical axis, and P can go here, okay, in the horizontal axis. So where would P be in relative to the ground? So P would start off at the ground, so it will start off at 0. P would also be at 1 quarter from the ground, sorry, halfway from the ground, so we call it P2. Sorry, P2, and then P would be all the way above ground, will be P3. Then we've got P4, about halfway back to the ground. Okay, so if we were to represent this in a graph, what would we do? So say this is top height and this is half height. We'll just draw a graph like this. Okay, this will be P1, this will be P2, this will be P3. I'll move this guy somewhere else, put him here, and then this is P3, got P4 here, and then back to P1, which is, well, P5 if we keep going in the circle. Okay, and then we can do another cycle to show, whoops, that's a bit too big, progression of P. Okay, that's something like that. So the graph should look something like this when you sketch it. Okay, so this will be P6, P7, P8, oops, and then P9. Okay, oopsies, there we go, and that's what the graph should look like. Alrighty, then this is it. You can have a look at your answers over here and see what questions you need to work on. Alright, thank you guys. We'll come back for volume 3 next week.